Welcome to our software team update. Since last time, we've been working very hard towards our ultimate goal, to develop all startup phases of Tachyum Prodigy computer from pushing the power button till the operating system lock on screen. The very first stage of this journey begins in BMC, a completely independent system that runs even when Tachyum Prodigy processors are turned off. BMC allows us to control the machine over the Ethernet. We can turn the machine on and off remotely. We can see the displayed output through an internet browser. We can check health, temperature and consumption of the machine in real time. And finally, we can perform system configuration. The first program that will execute while the machine is waking up or starting for the first time is the ROM code stored inside the processor. Its responsibility is to initialize all peripherals and perform power-on self-check. When everything is ready, we can proceed to the next stage, starting the firmware code stored in the flash memory chip and soldered on the main board. In this case, we're running UEFI application that is widely adopted by most of computer manufacturers and OS developers. It covers system checks, enumeration and verification of memories, enumeration of PCIe devices and other peripherals. To simply conclude, everything that is necessary to prepare the machine for starting the operating system. UEFI application takes care of the system integrity checks and so-called the chain of trust to ensure that the system was not compromised. UEFI application contains more than 2.5 million lines of code written in more than 6 different programming and scripting languages. We've managed to compile this huge project on our architecture and learn how to apply specific features of Tachyum architecture. We've also added very own features that will help us to quickly identify the health state of the machine. One of these tools is called System Event Log. Security settings include Secure Boot option and Trusted Platform Module support, both providing extended protection against malware attacks. Of course, the traditional options of BIOSes for configuring the boot storage devices is available as well. Furthermore, Tachyum-specific features include SMBIOS stable browser to see how the ROM and pre-EFI code identified installed devices in detail. System Test Package offers a set of small applications for quick verification of basic functionality of the system. Simply Memory Test writes predefined pattern into RAM and reads it back for memory regions which were not occupied by UEFI allocator. CPU Test verifies consistency of cache memories and executes simple ALU test. I/O Test checks communication peripherals by enabling loopback mode and sending short messages over UART and SPR interface. Every computing tile in the processor die has its own temperature probe. We have made an application for showing the current temperature reading and absolute maximum values since the machine startup to identify possible impurities and defects in the silicon die. This demonstration uses random number generator as the source for the temperature readings because we are running in an emulated environment. After checking the logs and setting up the machine, we are ready to run the operating system. In both cases, for the UEFI application demonstration and for running Linux, we use virtualization using QEMU software. We have recently switched from 6.1 to the latest version released in December 2021 to achieve the best possible emulation performance. Since we have very limited access to the FPGA hardware emulation platform and no physical processor was produced yet, this approach allows every developer at Tachyum to do his or her development independently. And when ready, it is possible to deploy the same binaries to the FPGA boards for final verification. In this part, we are running regular Linux kernel compiled for Tachyum Prodigy architecture and modified to use our low-level device drivers. Here, we can see what command line options we are passing to the QEMU software to enable network interface, real-time clock and symmetrical multiprocessing with 16 cores. After logging in, we have full-featured Linux kernel ready for experiments. Even for the Linux kernel, our developers upgraded the version from 5.10 we used earlier to 5.15 with end-of-life phase planned in October 2023. Let's try downloading some software package from GitHub and compile it. Maybe you've noticed that we used GCC for compiling source code. Even here, our software engineers, on par with the latest release, are proving their flexibility and showing high level of software development culture at Tachyum, allowing quick and seamless integration of latest technologies into our tools. Thank you very much for watching the Software Team Update video.